Bright Tuty. Every student matters.
Hello dear students, welcome to another lecture. In this class, we are going to continue with Unit 14 of Class 12 Education Nagaland Board, which is Measures of Central Tendency. Now, so far we have discussed about average or the arithmetic mean, how to compute the arithmetic mean when your series is individual, discrete or continuous, the three methods of calculating the same, namely the direct method, the assumed mean method and the step deviation method. Now comes median. In the simplest of languages, median is the middle value. It is that value which divides the entire distribution into equal parts. Okay? So median is the middle element, and for calculating the middle element, it is very important to arrange your series. So the series which is given to you should either be arranged in the ascending order or in the descending order. Okay, so that you can get the value which is dividing your series into equal halves. There can be a series which has odd numbers in it. There can also be a series in which there are even numbers in it, right? So basically, the positional average, median, is also known as the positional average. It tells the position of a number in the series. According to Connor, median is that value of the variable which is going to divide the group into two equal parts. One part will have the values which are greater and the other part will have the value which are lower than the median. And since it is the median that we are talking about, how do we denote it? It is MED or MD. Alright. Now, how do we calculate the median when my series is odd in number? What do I do first? I am going to arrange the data in either ascending or the descending order. Okay, so my data will be arranged in either the ascending or the descending order. And then I apply the formula n plus 1 by 2th term. What is n? N is the number of observations. Whatever is the number that you get here, that value in your series will be your median. For example, let us look at the example given here. This is the data which is given to you. 9 numbers are here. So I will first have to calculate the n 1 by 2th term. My n is 9. So 9 plus 1 by 2th term. What is it? 10 by 2th term, which is the 5th term. So what is the 5th term of the series? 1, 2, 3, 4 and 5. So my median in this series is 58. Simple enough it was. You simply had to apply the formula and calculate the median. What if your series is even in number? Now, if you can see, you have the age which is given to you. You can very clearly see that the age is not arranged. So the first thing you will do is to arrange it either in the ascending or the descending order. So we've arranged the age in the ascending order. So 19, 20, 22, 26, 28, 32, 38 and 45. Now, according to the formula for calculating median in a series with even number, what do we have to do? The formula is n by 2 plus the n plus 1 by 2th term divided by Now what is n over here? 8. So 8 by 2th term plus the 8 plus 1 by 2th term. Okay, so 8 plus 1 by 2th term is going to give me so this is the 4th term, right, plus the 5th term divided by 2. What is my 4th term? 26. 5th term 28 divided by 2, and on dividing it I get my median as 27 years. Okay, so if the data is odd, simply n by 2th term, where n is the number of series. If my data is even, n by 2th term plus n by 2 plus 1th term. Dividing the two, adding the two, you get your median or the middle value. Now comes the next type of series, which are the discrete series. Now we have learned what is a discrete series. We know that in discrete series we have frequency, right? That means how many times a number has been repeated in the series. Now, how do we calculate median in case of a discrete series? The first thing that you do is you will have to arrange if it in case it isn't arranged. Second, we will calculate the cumulative frequency. Also known as CF. Now, how do we calculate the cumulative frequency? Let us first discuss that. Let us see if, let me take the example again, marks. Frequency 1, 2, 3, 4. Okay. Now comes the cumulative frequency. What is my cumulative frequency? The addition that I am going to do to every frequency. Now just look at the way I am going to calculate it. The first frequency remains as it is. 1, 1. Second, what was the second frequency? 2. So you will add 2 to 1 and I get 3. Now, what is the next frequency? 3. So I will add 3 to 3, I get 6. Then was 4. I add 4 to 6 and I get 10. This is your cumulative frequency. Alright. Now let us look at the formula for calculating the median in case of a discrete series. We know how to calculate the cumulative frequency now, right? So look at this example. You are given with the marks of the students and you are given the number of students. So the first thing that we do is to calculate the cumulative frequencies. First was 10, remains as it is. Second is 10 plus 20, 30. 30 plus 30, 60. 60 plus 50, 110. 110 plus 40, 150. And 150 plus 30, 180. I have calculated my CF, my cumulative frequency. Now again I will apply the formula. Now what is the formula? It remains the same. I have n plus 1 by 2th term. What is my n now? N is the last cumulative frequency. What was my last cumulative frequency as you saw in this question? It was 180. So applying the formula, I get 180 plus 1 divided by 2, which is 9.5th item. Now you will see that 90.5 is close to which cumulative frequency? So 90.5 is close to this. Yes, we will always look for a higher number than what we have received. And what is the marks corresponding to this frequency? It is 35. So my median is going to be 35. So you will first arrange the data, calculate the cumulative frequency, apply the formula that we have learned, that is n plus 1 by 2th term. N is the last digit of your cumulative frequency. Whatever number you're going to get, look at what is it close to, and the marks or the observation corresponding to it will give you your. Okay. Now comes your continuous series. Now the continuous series, we have to apply the formula. Now in the continuous series also, I will first have to calculate the cumulative frequency. Okay, so I will be calculating the cumulative frequency. That is the first thing I shall do. Next, I will calculate n by 2th term. Okay. After I've calculated the n by 2th term, I will get the median class. In case of a discrete series, when you got the n plus 1 by 2th term, you found the observation which was closest to it and you got a number. Here we have the class. We will get a cumulative class, a median class. So, now we apply the formula, which is L plus n by 2 minus Cf upon f into I. Here, what is L? L is the lower digit or the lower item of the median class. Let's say the median class that I got was 20 to 30. So my lower number is 20 plus n by 2, the number you will get, minus the cumulative frequency of the median class divided by the frequency of the median class multiplied by I. I is the class interval, which is 10. And the value that you derive is your median. Let us look at the example. I have explained you the steps. Let us look at the example. This was the data which was given to me. Okay. 20 to 25, 25 to 30, 30 to 35, so on and so forth. Frequency was given to me now. I calculated the cumulative frequency. How did I do that? The first number remains as it is. 14 plus 28 gives me 42. 42 plus 33 gives me 75. 75 plus 30 gives me 105. 105 plus 20 gives me 125. 125 plus 15 gives me 140, and so on and so on. Right? Now, what do we have to apply? N by 2. What is my N? The last number of cumulative frequency, which is 160. Dividing it by 2, we get 80. What is this closest to? What is 80 close to? So 80 is obviously, yes. So 80, as I told you, we are always going to look at a higher value. So 80 is close to 105, and the median class corresponding to it is 35 to 40. Now let us apply the formula. Median is equals to L plus n by 2 minus Cf upon f into I. Okay. L is the lower limit of the class interval, which is 35. N by 2 was 80 minus CF. CF, as I told you, is the cumulative frequency of the median class. Cumulative frequency is the frequency of the previous class that we are going to take. So it is not 102, but rather, I'm really sorry, it is 75 divided by the frequency of the median class. So we'll take the frequency of the median class and the cumulative frequency of the class before it. So 10. Now let us simplify this data. 80 minus 75 is 5 divided by 30 into 10. Moving further, 35 plus 50 divided by 30. We get 35 plus 0.83. So my answer is 35.83. So what do we do in case of a continuous series? We calculate the cumulative frequency. From the cumulative frequency, we are going to get the median class, and then we have to apply the formula median that I have written for you. So the formula for median, I'll write it again, is L plus N by 2 minus CF upon F into I, where L is the lower limit of median class, CF is the cumulative frequency of the class preceding the median class, F is the frequency of the median class, and I is the class interval. So this is how we are going to calculate the median in individual, discrete, and continuous series. So before we wind up with the same, very quickly, let us just revise what is median and also learn why is it important, what are the merits or the demerits of calculating a median. So median means the middle class, the middle value, which is going to divide my observations in two equal halves. The class or the observations over the median are going to be higher, and then below are going to be lower. Median calculation is important because again you get a well-defined answer which is not vague, it is static. It is easy to calculate. We've learned that it is not affected by extreme values. Mean was affected by extreme values. If you remember, if we would add a higher number in my observation, my mean would change drastically. But in case of median, there is no effect if I add a higher value. Even if the extreme values are not known, we can calculate median because we just need to know the middle value of the data which is given to us. There are so many cases in which you can calculate median by just looking at the data rather than going into lengthy calculations. You can locate median graphically also, and it is not affected by the fluctuations in the sample, since median has got no effect of the extreme value. So even if the sample size fluctuates, my median is not going to fluctuate at all. And it can be calculated for the data which is based on the normal scale which is given to you. However, what are the demerits now? Median does not involve all the values of the data. For a data which has a large size, arranging it in increasing or decreasing order is going to be very difficult. We do not take median for further statistical or mathematical treatment, and in most of the cases it is sensitive. It does fall prey to some changes in the data. So this, my dear students, was median and the measures of calculating median and the merits and the demerits of the same.